Hello, in this lecture we'll find out the value of the green area. In the drawing we have rectangle ABCD. This is rectangle ABCD. But again, in the drawing we have rectangle ABCD. We know that side CB of this rectangle equals to 7 units in its length. Inside rectangle ABCD, we have, this is line segment CP, that is equals to 4 units in its length. This is line segment PQ, that is equals to 2 units. This is line segment QA, that equals to 5 units in its length. In addition, we know that this is angle CPQ, that is a right angle. And finally, this is angle PQA, it is also equals to 90 degrees in its size. I repeat again that our mission is to find out the value of this green area that is inside rectangle ABCD. So first of all, we'll join points C and A together by a straight line. And we define the intersection point of line segment CA with line segment PQ. This point is point M. So this is angle AMQ. And it is equals to this angle, this is actually angle PMC, according to the rule that the vertex angles are equal to each other. So if this angle is theta, then this angle must be also equal to theta because of the fact that those two angles are defined as vertex angles. And we know that vertex angles are equal to each other. So inside the right triangle AQM, inside this right triangle AQM, this angle equals to 90 degrees. This angle equals to theta, and therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, this equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, if we focus on this small right triangle, small green right triangle PCQ, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. It is given us the question that the length of line segment PQ is 2 units. So if we define the length of line segment AMQ as x, then PM must be equal to PQ minus MQ. Again, PM equals to PQ minus MQ. So write it down, PM equals to PQ minus MQ. So PM, this is line segment PM, that is equals to PQ. PQ is 2 according to what is given us in the question. minus MQ. MQ equals to X according to our definition. Therefore, in total, PM equals to 2 minus X. This is line segment PM that equals to 2 minus X. Okay. In the next step, we'll prove that the right grain small triangle PCM is similar to the right triangle AMQ. So I'll write it down. We'll prove that the right small grain triangle PCM is similar to this right triangle AMQ. This right white triangle AMQ. So why those two right triangles are similar to each other? First of all, those two angles, they are both equal to theta, therefore they are equal to each other. So this is angle PMC. In the right triangle PCM, in the right green triangle PCM, and it is equals to this angle, that is angle AMQ. In the right triangle, triangle AMQ. I'll repeat again. Angle PMC in the right triangle PCM equals to angle AMQ in the right triangle AMQ. They are both equal to theta, therefore they are equal to each other. In addition, those two angles, they are both right angles and therefore they are equal to each other. So this is angle MPC in the right triangle, the right green triangle PCM, and it is equals to this angle, that is actually angle AQM in the right triangle, triangle AMQ. Repeat again, angle APC, angle MPC, this is angle MPC in the right green triangle PCM equals to angle AQM in the right triangle AMQ. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is actually angle PCM in the right green triangle PCM, and it is equals to this angle, that is actually angle QAM in the right triangle AMQ. Repeat again, angle PCM in the right triangle PCM equals to angle QAM in the right triangle AMQ. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So I should found out that all the angles of this right green small triangle PCM are correspondingly equal to all those three angles in the right triangle AMQ. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. Angle triangle PCM is similar, this is the sign of similar, to the right triangle AMQ according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PM in the small green right triangle PMC over side MQ in the right triangle MQA is equals to PC, side PC in the right green triangle PCM over side AQ in the right triangle AQM. Repeat again. We will derive that PM over MQ equals to PC over AQ. PM equals to 2 minus X over MQ. MQ is X. And it is equals to PC. PC is 4 over AQ. AQ is 5. So actually found out that 2 minus X over X equals to 4 over 5. Here we will cross multiply this equation and we get that 5 times 2 minus X equals to 4X. We will open the brackets of this side of the equation, on this side of this equation, and we get that 5 times 2 is 10, minus 5x equals to 4x. Here we will add 5x to this equation, and we get that 10 equals to 9x. So here we will divide this equation by 9, and finally we will get that x equals to 10 over 9. So here x equals to 10 over 9 units. This is side QM, that is equals to x according to our definition, and we just right now found out that x equals to 10 over 9 units. Side PM equals to 2 minus x. 2 minus x is 2 minus 10 over 9 because x equals to 10 over 9. So 2 minus 10 over 9 equals to 8 over 9. Okay, so PM equals to 8 over 9 and MQ equals to 10 over 9. Okay, so in the next step, I'll copy this AQ, P, the line AQ, P, C in a new page, and we analyze this line AQ, P, C. Side AQ equals to 5 units in its length, and this is angle AQP that equals to 90 degrees in its size. Side PC equals to 4 units in its length, and finally side PQ equals to 2 units in its length. So actually this is the line AQPC that I copied from the original drawing. Here we will extend line segment AQ by a straight line. When you extend a straight line by a straight line, the result is a straight line. And therefore, this is a straight line. And we know that the sum of the angles the sum of the angles on the upper side of this straight line at point Q must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of this straight line at point Q? We have this angle that is 90 degrees plus the missing angle. In total, they must be equal to 180 degrees, according to rule 3 that I mentioned 1 second ago. Therefore, the missing angle here, so the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle here, that is to say angle PQ, whatever here, the missing angle here must be equal to 90 degrees in its size. In order to complete the sum of the angles on the upper side of this straight line at point Q to 180 degrees, the missing angle here must be equal to 90 degrees in its size. In the next step, we will do a construction, that is to say from this point C, we will do perpendicular on the extended AQ. Again, from point C, we will do perpendicular on the extended AQ. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point C in the extended AQ, this point as N. By doing this construction, we created quadrilateral PC and Q. This is quadrilateral PC and Q. Inside this quadrilateral PC, actually this angle equals to 90 degrees. Okay, this is angle QPC. This is equal to 90 degrees in its size. This angle equals to 90 degrees in its size according to what is given as the question. I just forgot to write it here. This angle is the right angle according to what is given as the question. So inside quadrilateral PC and Q, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. It's very simple. Why? Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. The missing angle here must be equal to 90 degrees in its size, and therefore inside quadrilateral PC and Q we have 4 right angles. And we know that according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral PC and Q as a rectangle. So this is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PC and Q, side PQ equals to side CN. But PQ equals to 2, therefore CN must be also equal to 2 units in its length. Likewise, according to the same rule, in the same rectangle, PC and Q, side PC must be equal to the opposite side QN. But PC is 4, therefore QN must be also equal to 4 units in its length. Okay, actually, side PQ equals to side CN. So I just write here 2 before we proved that CN equals to 2. But CN equals to 2 because of the fact that PQ equals to CN and PQ equals to 2, therefore CN equals also to 2. In the next step, we will join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle ACN. So, we will implement the Pythagoras theorem on this right triangle, triangle ACN. Here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle, triangle ACN, is AC, therefore the square of the hypotenuse is AC squared. and it must be equal to Cn squared plus An squared. So AC squared equals to Cn squared. Cn is 2, therefore Cn squared is 2 squared, that is 4, plus An. An in total equals to 5 plus 4, that is 9. Again, An in total equals to 5 plus 4, that is 9. So An is 9, therefore An squared is 9 squared, that is 81. So in total, AC squared equals to 4 plus 81, that is 85. In conclusion, we actually found out that AC squared equals to 85. Okay. So it is given us the question that ABCD is a rectangle, and we know that all the angles inside the rectangle are right angles. And especially this angle ABC, is one out of 4 angles in this rectangle ABCD. Therefore, it is equal to 90 degrees in its size. So in the next step, I will copy this right big triangle ABC in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle ABC. Here by PT is abbreviation for Pythagoras theorem. It is given us the question that side CB of this right triangle ABC equals to 7 units in its length. And we just right now found out that AC squared equals to 85. Here, we just right now found out that AC squared equals to 85. So in this right triangle, so this is the right triangle ABC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle ABC, AC squared equals to AB squared plus BC squared. AC squared is 85, and it is equal to AB squared. AB squared is the missing side, so we'll leave it as it is, plus BC squared. BC is 7, therefore BC squared is 7 squared, that is 49. So AB squared equals to 85 minus 49, that is 36. We take a root out of this equation, and finally we get that AB equals to the square root of 36, that is 6. So we found out that the length of this side AB of rectangle ABCD equals to 6 units. And we already know that CB equals to 7 units in its length. So what is the value of this green shape? The value of the green shape it is very easy to see from the drawing that the value of this green shape equals to the area of triangle ABC minus the area of this right triangle, triangle AQM, plus the area of this right green triangle, triangle CPM. Repeat again. The area of this green shape equals to the area of the big triangle ABC minus the area of this small triangle AMQ, this small white triangle, plus the area of the green triangle, triangle PCM. The area of the green shape equals to the area of triangle ABC minus the area of triangle AQM plus the area of the right green triangle, triangle CPM. So, what is the area of triangle ABC? The area of triangle ABC equals to the base of the triangle that is AB times the height to the base that is BC. The height to the base must create 90 degrees with the base, and indeed BC creates 90 degrees with the base AB. This angle equals to 90 degrees. So the height to the base is BC divided by 2. This is the area of triangle ABC minus the area of triangle AQM. What is the area of this white triangle, triangle AQM? We have to subtract the area of the white triangle AQM because we want to know what is the area of the green shape. Okay? So the area of triangle ABC minus the area of the right triangle AQM will give us the area of the green shape without this area, because the area of triangle ABC is not include this green shape, and therefore we have to add to the area of triangle ABC the area of this triangle, triangle PCM. So what is the area of triangle AQM? The area of triangle AQM equals to the base of the triangle that is AQ times the height to the base that is QM. Again, the height QM creates 90 degrees with the base AQ times the height to the base that is QM over 2 plus the area of this green small triangle, triangle PCM. What is the area of this small triangle PCM? It is equal to the base of the triangle that is PC times the height to the base that is PM. Why the height to the base is PM? Because of the fact that PM creates 90 degrees with the base PC divided by 2. So the area of triangle of the green shape equals to the area of triangle ABC, that is AB 6 times BC is 7 divided by 2. So 6 times 7 over 2 is the area of the triangle ABC, the big triangle ABC, minus the area of the white triangle, triangle AQM. The area of the white triangle AQM equals to AQ, that is 5, times QM. QM equals to 10 over 9. According to what we have already found out, QM equals to 10 over 9 divided by 2 plus the area of the green small triangle, triangle PCM. What is the area of this small triangle PCM? It is equals to PC, that is 4, times PM. We already found out that PM equals to 8 over 9 divided by 2. Six times 7 is 42, and 42 over 2 is 21. So the area of the big triangle ABC is 21 square units, minus the area of the white triangle, triangle AQM. The area of the white triangle AQM equals to, here we have 10 over 2 is 5, and 5 times 5 is 25. So in total, this expression equals to 25 over 9 plus the area of the green small triangle, triangle CPM. And this expression equals to 8 over 2 is 4. 4 times 4 is 16. So in total, this expression equals to 16 over 9. So the area of the green shape in total equals to 21 plus 16 over 9 plus minus 25. So the area of the green shape equals to 21. Here we have 16 minus 25 is minus 9, and then in the denominator we have 9, so it is minus 9 over 9. So the area of the green shape equals to 21, and minus 9 over 9 is minus 1. So the area of the green shape equals to 21 minus 1, that is 20. In conclusion, I should found out that the area of the green shape is equal to 20 square units. Repeat again. The area of this green shape equals to 20 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this green shape. So in the drawing, we have rectangle ABCD. In addition, we know that side CB of this rectangle equals to 7 units in its length. Inside rectangle ABCD, we have this is line segment CP that equals to 4 units in its length. This is line segment PQ that is equals to 2 units in its length. This is line segment QA that is equals to 5 units. This is angle CPQ, that is a right angle. This is angle AQPQA, that is also a right angle. I repeat again, our mission is to find out the value of this green shape. Okay, so in the first step, we joined points A and C together by a straight line. And we defined the intersection point of line segment CA with line segment PQ, this point as M. By doing this construction, actually created here two vertex angles, and you know that vertex angles are equal to each other. So this is angle PMC that is equals to this angle, angle AMQ. So this is, if angle PMC, this angle equals to theta, then this angle AMQ must be also equal to theta, according to the rule that vertex angles are equal to each other. So if we focus on this right green triangle PMC, this green triangle PMC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, this equals to 180 degrees, that is the sum of the angles in any triangle. Likewise, if we focus on this right triangle AQM, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Okay, so it is given us the question that PQ equals to 2 units in its length. So we defined QM or MQ as X. Therefore PM equals to PQ minus MQ. Again, PM equals to PQ minus MQ. Here PM equals to PQ minus MQ. PQ is 2, according to what is given as the question. MQ equals to X, according to our definition. So in total, PM equals to 2 minus X. So according to our definition, MQ equals to X, and we just write down for now that PM equals to 2 minus X. In the next step, we proved that those two right triangles are similar to each other. That is to say, we proved that this right triangle PMQ is similar to this small green triangle PCM. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually found out that all the angles inside the small green right triangle PMC are correspondingly equal to all the angles inside this right triangle AMQ. Therefore we proved actually that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationships exist between their sides. We will derive that PM over MQ equals to PC over QA. Repeat again, we will derive that PM over MQ equals to PC over AQ. PM is 2 minus x, MQ is x. Repeat again, PM is 2 minus x, MQ is x. PC is 4, AQ is 5. So in total we found out that 2 minus x over x equals to 4 over 5. Here we just multiply this equation and finally found out that 5 times 2 minus x equals to 4x. Here we open the brackets on this side of the equation and finally we found out that 5 times 2 is 10 and 5 minus x is minus 5x. So 10 minus 5x equals to 4x. We added 5x to this equation and finally found out that 10 equals to 5x plus 4x, 5x plus 4x is 9x. So 10 equals to 9x, we divided this equation by 9 and finally found out that x equals to 10 over 9. So actually, this is side M and Q, that is equal to x, and we just found out that x equals to 10 over 9. And according to what we already found out, PM equals to 2 minus x. X is 10 over 9, and therefore 2 minus x is 2 minus 10 over 9, that is 8 over 9. So in conclusion, we found out that PM equals to 8 over 9 units in its length. In the next step, I copied this line AQPC in a new page and realize this big line AQPC. So this is the line AQPC that I copied from the original drawing. So here we know that side AQ equals to 5 units in its length, side PQ equals to 2 units in its length, and side PC equals to 4 units in its length. In the next step, we extended side AQ by straight line. When you extend the straight line by straight line, the result is a straight line. So this is a straight line, and this angle equals to 90 degrees. And we know that the sum of the angles on one side of a straight line is equals to 180 degrees. So if we focus on the upper side of this straight line at point Q, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of this straight line at point Q? We have this angle that is a right angle plus the missing angle. In total, it must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, from point C, we draw perpendicular on the extended AQ. Again, from point C, we draw perpendicular on the extended AQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and the extended AQ as N. By doing this construction, we created quadrilateral PQ and C. This is quadrilateral PQ and C. Inside this quadrilateral PQ and C, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees inside. Because it is very simple, 270 degrees plus 90 degrees, it is 360 degrees. That is the sum of the angles in any quadrilateral. Therefore, this missing fourth angle must be equal to 90 degrees in its size. So inside this quadrilateral PC and Q, we have 4 right angles. And according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate to this quadrilateral PC and Q as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PC and Q, side PQ must be equal to the opposite side CN. But PQ is 2, therefore CN must be also equal to 2. Likewise, according to the sum rule, in the same rectangle PC and Q, side PC must be equal to the opposite side QN. But PC is 4, therefore QN must be also equal to 4 units in its length. In the next step, we join points A and C together by side tying. By joining points A and C, we created the right triangle, triangle A and C. In the next step, we implemented the Pythagoras theorem on this right triangle, triangle A and C. Here, by PC is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle A and C is AC, therefore the square of the hypotenuse is AC square, so AC square must be equal to CN square plus NA square. Again, AC square equals to CN square plus AN square. So AC square equals to CN square. CN is 2, therefore CN square is 2 squared, that is 4, plus AN square. AN in total equals to 5 plus 4, that is 9. And AN in total equals to 9. Therefore, AN square is 9 squared, that is 81. So in conclusion, in total, we actually found out that AC square equals to 4 plus 81, that is 85. So AC square equals to 85. AC square equals to 85. So here we know that ABCD is a rectangle, and we also know that all the angles inside the rectangle are right angles. And especially this angle is one out of 4 angles of this rectangle ABCD, therefore it must be equal to 90 degrees in its size. In the next step, I copied this right big triangle, triangle ABC, in a new page, and we implemented the Pythagoras theorem on this right big triangle, triangle ABC. This is the right big triangle, triangle ABC that I copied from the original drawing. Here by PT is a version from Pythagoras theorem. Side CB is one side of rectangle ABCD that is equal to 7 units in its length according to what is given as the question. We have already found out that AC square equals to 85. So in this right triangle ABC, AC square equals to AB square plus CB square. Again, AC square equals to AB square plus CBC square. AC square is 85. And it is equals to AB square is the missing side, plus BC square. BC is 7, therefore BC square is 7 squared, that is 49. So in conclusion, we found out that 85 equals to AB square plus 49. Here we subtracted 49 from this equation and finally found out that AB square equals to 85 plus 49 is 36. So AB square equals to 36. We took a root out of this equation and finally found out that AB equals to the square root of 36, that is 6. So this is side AB that is equal to 6 units in its length. So what is the area of the green shape? From the drawing it is very easy to see that the area of the green shape equals to the area of the big triangle, triangle ABC, minus the area of the white triangle, triangle PQA, because we want to know what is the area of the green shape. Therefore we have to subtract from the area of triangle ABC the white area of triangle AMQ, and we have to add to the area of this triangle ABC the area of the green triangle, triangle PCM, because we want to know what is the area of the green shape. So in total, we found out that the area of the green shape equals to the area of the big triangle, the big right triangle ABC, minus the area of the white triangle AQM, plus the area of the small green triangle CPM. What is the area of the big right triangle ABC? The area of the big right triangle ABC equals to the base of the triangle that is AB times the height to the base that is BC over 2. Repeat again, the area of the triangle ABC equals to the base that is AB times the height to the base that is BC over 2. Minus the area of the white triangle PAQP. AQM. The area of the right triangle AQM equals to the base that is AQ times the height to the base that is QM over 2. Repeat again. The area of the right triangle AQM equals to the base that is AQ times the height to the base that is QM over 2. Minus the area of this green small right triangle PMC. The area of this green small right triangle PMC equals to the base of this green small right triangle that is PC times the height to the base that is PM over 2. Repeat again, the area of the green small right triangle CPM equals to the base that is PC times the height to the base that is PM over 2. So here AB is 6 times BC that is 7 over 2 minus AQ is 5 times MQ that is 10 over 9 divided by 2 plus the area of the small green triangle PCM that equals to PC that is 4 times PM that is 8 over 9 divided by 2. 6 times 7 over 2 is 21. That is the area of triangle ABC. Here we have 10 over 2 is 5. 5 times 5 is 25. So in total this expression equals to 25 over 9. That is actually the area of the white triangle AQM plus the area of the green small triangle CPM. The area equals to, here we have 8 over 2 is 4, and 4 times 4 is 16. So in total this expression equals to 16 over 9. So in total we actually found out that the area of the green shape equals to 21 minus 25 over 9 plus 16 over 9. So it is 21 plus 16 minus 25 over 9. 16 minus 25 is minus 9. And in the denominator we have 9. So in total, the area of the green shape equals to 21 minus 9 over 9. Minus 9 over 9 is minus 1. So in total, the area of the green shape equals to 21 minus 1, that is 20. In conclusion, we actually found out that the area of this green shape equals to 20 square units. Okay, thank you very much.